This optimization problem is about finding the maximum area of a rectangle under a curve of y equals to 2 over 2 plus x squared. So we have a function or equation y equals to 2 over 2 plus x squared, and the graph of this function looks like a bell. And then what we are trying to do is I'm trying to construct a rectangle under the curve. So I gave you a rectangle over here, and then one of the side is on the x-axis. So this side is on the x-axis, and then this rectangle has two vertices that is on the curve. So one right here and then one right there. So what I am asking you to do is I am asking you to find the coordinate of these two vertices. So one on the right and then one on the left. So tell me what those coordinates are such that the area of the rectangle is maximized. And then you might be asking, hey, you already have the vertices is x comma y, right? So this one, I am not saying that this is the exact location. I am saying that you have a curve and then you are trying to construct a rectangle based on the description, and then this is what you expect to see. I'm not saying that the coordinate you see on the picture right now is the final answer. All right, so this one this is an optimization problem. So optimization problem involves with a graph, and then after the graph you have to define the variables. So this one, the variables, they are x and y, and then the next step is you have to tell me the primary and the secondary function. So what are we trying to do? What is the question asking? The question is asking for maximum area, right? So it's asking for the area of a rectangle. So the primary function will be the 2x times y, and then what about the secondary? The secondary is what is given. So in the secondary, we know that y is equals to 2 divided by 2 plus x squared. There is nothing to rewrite. It is what it is. So that is the secondary. The secondary function is what is given, and then the primary is the area. So what is the area of this rectangle? So the area is equals to 2x, right? 2x and then times y. Okay, so we have area equals to 2x times y. This is one function in terms of two variable, and then we cannot just take the derivative like that, and then before taking the derivative we have to change y in terms of x. So that means we have to plug in the secondary to the primary, and then we have a equals to 2x times y. The y is now multiplied, so 2 divided by 2 plus x squared. So since there is one independent variable x, so I will just call this a of x. Area, this is an area function. The independent variable is x, and then you clean up the numerator. So that is a of x equals to 4x divided by 2 plus x squared. And then our primary is ready, and then the next step is you want to find maximum, right? So you are looking for a local maximum. So for local maximum, we need to look at the slope. So for a local maximum, the slope must be increasing and then constant, increasing and then 0 and then decreasing. So going up, and then a constant a horizontal tangent line means the slope is equal to 0 and then decreasing. And then to get this information out, we have to take the derivative. So take the derivative. This one will be a quotient rule. So for quotient rule, we always square the denominator. That is 2 plus x squared, and then we square the denominator. The derivative of 4x is equals to 4. We copy the denominator, and then minus 4x, the derivative of the denominator is equals to 2x, and then we set this equals to 0 to look for what x value gives you a horizontal tangent. All right, so clean up the top. So you have a prime of x equals to 8 plus 4x squared minus 8x squared, and then divided by the denominator, 2 plus x squared, and then square. And then what do you have? You have a prime of x equals to 4 minus 8, that is a minus 4. So you have 8 minus 4x squared divided by 2 plus x square, and then you set that equals to 0. How do you solve for this? You have the numerator divided by denominator equals to 0. To get a 0, the numerator has to be equals to 0. So a minus 4x squared must be equal to 0. And other way to think about this is you multiply the denominator on both sides. All right, and then you solve for x. You have a equals to 4x squared. Divide both sides by 4, you have 2 equals to x squared. And then what is x equals to? X is equals to, so x is equals to square root of 2. Am I missing anything? Yes, is equals to plus or minus 2 because the power is even. So for the second power, fourth power, 6, 8, 10, 12, 14, as long as the power is even, when you do the radical, you have to use a plus or minus. For art, like the third power, the fifth power, the seventh power, so on and so forth, you do not need to use the plus or minus. So we have x equals to positive, so when x is equals to that, and then the next step is you have to get the y coordinate. So we have x equals to 2 value, right? So when x is equals to positive square root of 2, what is y equal to? Y is equals to 2 divided by 2 plus square root of 2, and then you square that. That is equals to 2 divided by 4, right? 2 divided by 4, that is equals to 1/2. So the xy coordinate is square root of 2 and then comma 1/2. And then how about x equals to negative 2? So when x equals to negative root 2, we have y equals to 2 divided by 2 plus negative root 2 square. You get the same thing because you square a negative. So you still have a 1/2, and then the other coordinate is minus root 2. So minus root 2 comma 1/2. That is the coordinate. So now we have the two vertices, one right here and then one right there. All right. And then what is the next step? The next step is we should write our conclusion. So let's use a different color to do that. So we have two vertices, and then the first one is root 2 comma 1/2, and then the other one is negative root 2. Gonna get rid of that. So negative root 2 comma 1/2, and then how about on the x-axis? So on x-axis, what do we have? On x-axis, so you can use the graph above for a reference. So we already know that x is equals to root 2. So that will be a root 2 comma 0. So where is this point? This point will be the bottom right hand corner, right? And then on the left side, we have negative root 2 comma 0. There you go. You have those four corners of the rectangle. And then can you do one more step for me? So you are looking for the maximum area. Can you give me a proof that when x is equals to root 2 or negative root 2, the area is maximized? Can you? Okay, so here is how we are going to do this. So let's switch to whatever. Let's switch to this. Okay, so we have to draw a number line. So we have do we need to use a 0? I don't think we will need to use a 0, right? Because 0 is not a critical number. So we have a negative root 2 and then a positive root 2. I need to prove that at these 2 points, there is a maximum. So this one I will, this is approximately equals to 1.41. This is negative 1.41. So this one I will just do from root 2 to positive infinity. This one negative root 2 to root 2, and then this one is from negative infinity to negative root 2, but that is not important. So this one, how about x equals to 1? How about x equals to 2? How about x equals to negative 2? So this one, and then you will be testing that. So at a prime, so at a prime equals to 1, you have a, you will be using this. Okay, so a plus 4 x squared minus ax squared. So we have a plus 4 1 square, and then minus 8 times 1 square divided by 2 plus 1 square, and then square. That one gives you a greater than 0, and then a prime of 2, that gives you a less than 0. So this one will be increasing, this one will be a decreasing. So at that point, there is a maximum. All right, and then that's it. So when x is equals to root 2, we have a maximum, and then that is the end of this video. If you liked it, give me a like, share, and subscribe, and I will see you all in the next one. Signing out.